So I am delighted to welcome this preeminent panel. And I would like to kick things off by inviting the panelists to share a few thoughts about what they think about physical intelligence. And so let's see, maybe we start with David.
Hi, good morning, everyone. I would like to talk a little bit about context of aerospace maintenance. So I think most of you have been to the airport. You see, aircraft maintenance happening at the airport. Of course, besides line maintenance, there is also work that happens in the hangars. There are work that happens at the component space, meaning, for example, engine being a big component. We tear it apart, and then we do inspections. We do whatever we need to do in terms of servicing, and then we disassemble it into smaller parts, and those parts go for example, fan blades. We actually do further work on them. And so there's different type of business. There's still also a group of people that sit in the aircon room that look at reliability program, repair design, and all that. But most of the people are working next to the component. In terms of context, I think a few points, 4 points actually. Firstly, aerospace is a very heavily regulated industry, right? In terms of maintenance, certification, personnel, and also in terms of certification of design of the aircraft. So it takes very long for any new technology to make its way onto the aircraft. Another point is that in the design of airplanes for maintenance, we are actually looking at the OEMs, the aircraft designer, are looking at the lowest common capability, meaning they don't design an aircraft to be maintained by only the most sophisticated organizations, right? It needs to be able to work, to be able to be maintained by people who do not have really high-tech means. It's very labor-intensive, as I already mentioned. Other than automation at the component repair level, most are still very much human. And my last point is there's this element of accountability in maintenance, meaning who was the last guy who did this, and he signed his name on it. He goes to jail if he was, criminally negligent. So all of these elements, in terms of the context of where we applied robotics and AI, as well as those challenges that I mentioned, are all key elements that we need to consider when we look at, physical intelligence. Thank you.
Thank you. So, sorry, we have Professor Armando Sola-Lazada joining us also. Please join. Sorry about that. Please, yeah. Armando is actually the deputy director of CCO at MIT, the largest lab. He's also a specialist on the neurosymbolic programming there. So thank you, Armando, for joining. Sorry about that, Roman.
Yanling.
Good morning, everyone. Thank you, Daniela. So in Changi Airport, we're actually very resource intensive. We have about a workforce about 50,000 people. So you can imagine anything from cleaning to baggage handling to even security screening. There are so many people that's involved in running the entire airport. And this has always been a constant struggle in aviation because we're so resource intensive. Where do we even start looking at automation and robotics? So we have done our foray into automation. You would see some of it when you're coming through us as passengers. You could be our cleaning robots, our vacuum cleaners, for example. And the next one that we're really looking into is autonomous vehicles. So autonomous vehicles that will bring our baggage to and from the aircraft itself. And all this involves automation working in context of humans, right? Not just our staff, also passengers. So how do we make it really intuitive for people? How do we make it really safe for people, right? And then lastly, how do we make it delightful for people? I think that's something that we're really looking into at Changi Airport, and that really is part of our mission that my team and I are driving.
Awesome. Gaurav.
Thank you so much. Thanks for having me here on the panel. I think Daniela framed the constraints of the problem really in many ways. They're very close to the way I think about it. For a roboticist, in many ways, there's a certain arrogance in suggesting that the only intelligence worth studying is physical intelligence. You may or may not agree with this, but many of us have made it our life's mission to focus entirely on embodied intelligence. And the reason is simple. All natural intelligence is embodied intelligence. That's number one, just something worth keeping in mind. Number two, all naturally occurring intelligence is remarkably energy efficient. In a few tens of watts, your brain can do far more than what most megawatt-powered artificial intelligence techniques can do. Number three, all naturally occurring intelligence tends to fail gracefully. It isn't perfect, but it fails well. The art of failing well is something we haven't learned in machine intelligence. And I think that for physical intelligence, and Daniela alluded to these three properties, are some of the most exciting challenges of our time. I was talking to General earlier today and a couple of days ago, and sometimes there's this refrain, what should academics studying machine intelligence do? After all, it's heavily industry dominated. We just articulated three problems that nobody in industry has the answer to, and there's a whole vista of physical intelligence problems to be studied. So it's a remarkably exciting area.
Amazing, inspiring. Okay, Sheng.
Yes, thanks, Delina, and thanks for inviting me here. Let me just try to set the stage a little bit about GovTech, because I'm not sure, like there are many government people around here, so just trying to explain the role of GovTech and what we are first in the context of this particular panel and what we are talking about today. So GovTech is one of three technology agencies within the Singapore government. And if you look at it, then there's DSTA, the Defense Science Technology Agency, which is very focused on defense. They serve the MINDEF. There's HDX, Home Team Science and Technology Organization Agency, which serves the Home Team, the Singapore Police, prisons, the border control, and so on and so forth. And then there's GovTech. So GovTech basically covers the rest, right? So I want to explain this is because the scope of what GovTech does is very wide. And actually the physical interfaces with technology is only one segment of what we provide. But we do provide some of these things, like especially to the infrastructure agencies, like JDC, URA, PUB, NEA, and so on and so forth. So we do actually provide technology to them. But in the world where we have today, there is actually, in terms of technology, there is what we term as IT, where it's more digital, it's more informational, and then there is OT, where it's more operational. I think a lot of the things that we talk about just now, that I heard just now, and the panel here talk about today, it's probably more related to OT, and also a little bit related to the world that I was previously from, Singapore Power, where we deal a lot with utilities, with power, very operational kinds of technology. So I think in the panel discussion later, I'll probably talk about some of the work that we have done with one of the agencies, the infrastructure agencies, and we can elaborate more at a later point in time. Thank you.
Armando, your opening remarks.
Sure. It's been really amazing in the last few years to, for example, have a lot of these AI tools like Copilot help me write my code more efficiently. But what would really change my life is to have a Copilot for my laundry, or for emptying the dishwasher and cleaning up my kitchen after I cook. And this is the sort of thing that really requires that kind of interaction with the real world. And it's very different from a robot in a factory or a very controlled environment. Let's just say my house is not a very controlled environment. That's kind of an understatement. So we really require the kind of technology that can deal with, I'm not going to say mess because my wife would get angry at me, but that can deal with the kind of unstructured environment where you can't quite predict where things are going to be the next day, where you can't quite predict exactly how the clothes are going to come out of the washing machine. And it also requires a level of knowledge about the world that, for example, allows me to tell the system, hey, I want you to take the silverware out of the dishwasher and put it in the drawer, without having to explicitly describe exactly how to put it in the drawer and exactly which slot it goes. It requires a kind of knowledge about the world that I think for the first time in many years, we actually have within reach, thanks to the kind of foundation models that we have available to us. I think this is a really exciting time to finally get to the point where we can have the level of assistance that science fiction has been promising us for many years.
Well, Armando, I think you set up the stage for my first question very well, because you did say that we have foundational models that are enabling robots or machines, co-pilots, physical co-pilots, to know exactly how to take the silverware from the dishwasher and put them in the drawer. But I'm going to ask, do we? In fact, I'm going to ask what is really needed in order for AI to get out of the digital world into the physical world in your business, for those of us in business. And what do you think is needed technically in order to make the leap? And let's see, David, maybe we can start with you. And
Okay. Yeah. So I guess the ability for robots to work side by side human is definitely something that is really key. Soft robotics and also the ability to perceive what is going on in the environment, as well as your collaborator, human collaborator. So I use the example of the project that we are thinking of, which is doing a wheel change in the Changi Airport for an aircraft, and typically this is done by by up to 3 person as a team, and I think that we can design the robots to do various things in terms of lifting, alignment, doing a lot of the heavy lifting in terms of tightening the bolts and all that. But I think when we changed an operations from a 3-man team into a 1-man operations with a robot, to me, it brings to question what are the other team members actually doing? What are the actual human team members offer other than the physical support to complete the task? What I mean by that is, if I am working with a team, I may ask my teammate, what do you think? If I'm working with a teammate, I also expect my teammate to look out for me if I make a mistake, if I forgot something, or if I am not feeling well. So I think for us to really go into the fully autonomous, in the future, this element, perception, and how after that be able to collaborate with the human beyond just that task, but also overall is something that I think is something that we need in terms of the AI capabilities.
so you want the AI to be a kind of a friend or a guardian to help you from making mistakes, and also to be empowered to understand your intent and project forward in order to figure out what would be needed or what is needed for the next step of the task. Yeah? Which one? Friend, guardian, teammate? What's most important?
Well, I think as a start, of course, it will help you do the task. So it's really a collaborator. But I'm just thinking that as we look at the next level of capability, all these other elements will come in. Probably not as a friend, but someone that look after you first before it really can sing with you while you're doing work, whistle with you. That comes later, I guess.
Yan Ling, what do you think?
Maybe I'll share a bit about baggage handling in Changi Airport. So baggage handling, if you know, in Changi Airport, looks the same as baggage handling probably in 1920s when commercial aviation first started. And this happens internationally simply because design aircraft, the way in which speed is required in turning around an aircraft. So we've been dabbling with baggage robots for a while now, and it is an incredibly difficult task because bags comes in all shapes and sizes, right? Some of them are soft, some of them are hard, come in all sorts of dimensions, and that is really, really painful for the robots to learn. It's something so difficult, even though it seems really simple and intuitive to a human being. How do I hold? How do I balance the weight? Etc. So after some seriously long testing, years of testing, we managed to get one robot to move a bag, a regular hard case bag, in 37 seconds, which is way below the sort of speed that we require to work. So that was about a year or two ago. And at that point, we were thinking, robots, maybe another 10 years before it happens. But I think the course of last year gave us a lot of hope, right? Generative AI and how it's influencing robotics development right now. I am a little more optimistic today that eventually we'll have a robot who is able to assist human beings with work that is really tough. You have to be out there in rain, in thunder, in lightning, in sunshine, in order to deliver the sort of service that everyone should deserve. And this is something that I think as a company we're looking forward to and working with our partners to deliver. Yeah.
But Yang-Ling, what would you like for robots to do with baggage that they cannot do yet?
So right now they are supposed to do two things, right? With speed, turn around the aircraft in time. Second thing, to be able to handle all the bags that are coming from the aircraft itself. Right now they aren't able to achieve both. Yeah, but I have hopes that in time they will be.
So there is the task of loading the luggage onto the luggage carts, and then there's the task of driving the luggage carts.
So there's task of loading, driving, and unloading. So it's
Right.
two-way sort of traffic. For the driving part of our task, we're looking at autonomous vehicles, and I think that is highly possible. And we're looking at redesigning our process rather than a human following the baggage cart to and from the aircraft, of which 50% of their time is wasted on traveling. We want to redesign the process such that human beings are at the ends where they do the
Exactly.
loading,
So the
unloading.
robot can drive the baggage cart
Exactly.
can drive
Yeah.
itself from one location to the other, and
so
then
the baggage comes to you as
Exactly,
the staff. So
exactly.
this is something that we've been trialing for the last 3 years in Changi Airport, and we're very hopeful that it will work. We're going to advanced trials right now, and hoping to deliver this in 2026.
Awesome. Well, I have great hopes for that. What do you think, Gaurav?
So
It's easier than robotaxi, no?
it's easier than robotaxi. I didn't know you were going to talk about baggage handling. So after this panel, I made a note. My student who just graduated has a startup on baggage handling. I am going to connect him to you.
Thank you.
But since we're not supposed to do advertising here, I wouldn't say the name of the startup here. But mental note. But I think the question, Daniela, you asked earlier about foundation models is very apropos. And I think the question you asked is, do we in fact have the right foundation models?
Exactly.
And I think the answer is we don't. The way I see the field right now is we have foundation models that do certain things, and there is pretty much a big frenzy to coax those foundation models into becoming good for robotics. In fact, the paper that won the Best Paper Award at ICRA 2 months ago was co-authored by 175 people. Maybe some of you are co-authors, I don't know. Which basically took a transformer that Google already had and tried to coax it into being good for doing robot manipulation. And the results are pretty good. But it is sort of a one-off, right? This is likely not the future. Because
Also, Gaurav, like I do want to say, the physical world, especially the manipulation tasks, require knowledge about forces and torques, and how do you get that from text?
Exactly. And
From video.
So I think we are at sort of level 0 on this, right? We're trying to take something that's good at predicting next token generation, and it's going to be good in some limited ways at generating kinematic motions at any rate for robots, and you're going to get some initial success. But I think the real future for true foundation models for robotics is constrained foundation models. Models that operate under strong priors, under strong energy constraints, typically in embodiment. And there's a school of thought that suggests that certain kinds of simulation techniques might be good for building such models. And there's a school of thought that says, no, you have to do it all in embodied reality. Time will tell. But I think my answer to your question, Daniela, is that we don't quite have the foundation models yet. This is an exciting new area to build really good foundation models for robotics.
What would you like to have in the foundation models?
I think...
Because right now, when we talk about foundation models, we say text, or maybe we say text and images, and maybe video. But is this enough?
I think it's not. I think multimodality refers to the three things you mentioned. I think the key missing component is our measured forces and torques. which really, I mean, your baggage handling example is a classic example of that, right? Two bags can look alike. If one is 50 pounds heavier than the other, the robot has to substantially do something different. And that is not something you do easily just by video or just by text.
So I'm going to go to Armando because we started this whole conversation with a statement that he made. So let's stick with the technical challenges for now, and we'll come back to business challenges. Xiaoshong, you can close us on a positive note. But Armando, Armando, how do you see the evolution of foundational models, and like what do you think is happening?
Well, so I think a couple of things. One is when it comes to manipulations and a lot of the complexities of manipulation, I don't think we're going to get there just by, getting lots of text from the internet. You really need specialized models trained to deal with those complex tasks. However, I do think that for a lot of those complex manipulation tasks having to do with very unstructured objects, there is going to be a very important role for data-driven, learning-based approaches. Ideally, ones that are neurosymbolic and that can combine some of that physics knowledge that we have coming into the process. But I think there is also another aspect of making these kind of assistants real, which is the interface aspect, right? And I think for that, actually, even a lot of these existing foundation models can play a really important role, right? If I just got all my groceries in my house, knowing that the milk goes in the refrigerator, but not the canned beans, that those go in the cupboard, right? This is the kind of world knowledge that I think existing models actually have a fair bit of, and can be, pretty reliably expected to know that generally we put milk in the refrigerator. And so that can be a huge enabler to systems that can interact with people at a more natural level, that don't require the kind of super low-level description of exactly what you want them to do and how to do it. And I think that is really going to be essential if you actually want to have these kind of assistants in the household interacting with people who are not programmers, who don't know how to describe things at the level of precision that we computer scientists are used to talking about things.
So I am actually quite excited about bringing language into the reasoning loop of a physical machine. Now, physical machines have a huge advantage over the digital world because physical machines operate under the laws of physics. They operate under the laws of geometry. We have a lot of theories about geometric and physics theories about how the world operates. The digital world is mostly statistics at the moment. And so there's something really powerful about geometry and physics. But at the same time, reasoning about the world through our traditional inputs with cameras and lasers is actually very, very time-consuming, and it's kind of low level. You reason really well, but you reason about XYZ coordinates. You don't really reason about abstractions. And so by connecting the physical world, the perception aspect of the world with language, we perhaps have the ability to raise the level of reasoning of machines into more abstract spaces. And so I just want to share a story. For some time now, we've been working on autonomous vehicles. This project started actually right here in Singapore together with a number of friends who are in the room today. And so we started in 2010 to build self-driving vehicles in Singapore. And it was an extraordinary project. We've continued that with support from Toyota. And every time I showed a huge advancement, or at least something we thought was a huge advancement, to Toyota, the question was, Daniela, this is great, but what will your vehicle do when a plane comes comes for an emergency landing on the highway? How do you know what to do? And so this question always stumped us. But now, with the connection of language into the perception system of vehicles, we actually have the ability to look at an input that shows a plane landing on the highway, parse that and describe it in words as plane landing on the highway, and then in the word space, in the language space, reason to figure out what to do. This is extraordinary because we really are pushing the boundaries of what is capable. So there's something really powerful about bringing the AI ability to reason about text and images and other digital data into the control loop of a vehicle. And so now I know this sounds kind of like an abstraction that we're all excited about. I mean, how many times do we actually see a plane landing on the highway? But Xiaosheng, bring us home with something something powerful that we can do today.
I'm not sure I can do that because I think there's a lot of positivity, and it's not that I want to inject anything that's negative, but I just want to bring up some challenges that we have to deal with. I think first of all, not everything is a technical challenge. The number one challenge we often face is really whatever we do here, it needs to bring value, right? Because at the end of the day, it is about what you do, what kind of value add it brings to lives of people. But at the same time, how does it replace whatever is existence? Because a lot of things that we talk about today, like how can it improve my laundry experience? But if it improves my laundry experience, but I need to pay another $1 million, would I want to do that? So I think the value part of the equation is actually pretty important. And if we cannot solve that, I think it would just not go anywhere, right? Because even as we have a lot of these discussions about AI and LLMs, I see increasing number of articles. I was just reading one from The Economist this morning that talks about, there's so much money now that's been dumped into AI. The value that it's actually coming back is not high enough. And I think many of you probably know about the few AI winters that have gone through before. So I'm not to be totally negative. I think the kind of new things that are coming up makes me very optimistic about it in the industry. And being long enough in the industry, I know it always comes in waves. But at the same time, I think as technologists, we probably need to be a little bit more cautious and when we were looking into this. And the other thing that I just wanted to bring up, especially talking about the physical world, right? This is less of what I've done in GovTech, but what I've done in my previous roles in Singapore Power, where I actually deployed IoT devices out to the market. And I'm a software engineer by training and by trade for most of my years. And I've been dealing with software mostly in my career. And software, it does fail. There are bugs and so on. But the failure is a very different kind of failure. But you put physical devices out into the real world, the kind of failure rate is very, very different, right? So I deploy a lot of devices out in the market to control various kinds of equipment and bring data back and so on and so forth. And lo and behold, then how will it fail, right? And how will it fail is not because of my software, but how will it fail is because the hardware, the environment it is in, and the failure rates are very, very different as well, right? If I put it near a building, which is next to the sea, is very different from I put it in a controlled environment inside a building. So I think some of these things probably, as we try to marry AI into the real world, that especially for the people who are more used to dealing with software, just have a care about the hardware that it actually goes into, because that is a very important equation as well.
I just want to say that as an academic, I want to our belief is that in academia we demonstrate what is possible, and then we take advantage of economies of scale and manufacturing processes to get the costs down. I will observe that the first color printer cost $500,000 in the 1980s. And so I have, and so today we have throwaway color printers. And so I like to believe that we're on a similar path with physical intelligence. I don't know how long it will take, but I'd like to believe that we will first have these enormously costly devices, but then the price will come down. For instance, Unitree just released a humanoid robot that costs $16,000. Now, that is an extraordinary achievement. It's the robot. I don't have one yet. I'm trying to get one. But that robot, in videos, it looks really capable. And it is an order of magnitude, at least, maybe 1 to 2 orders of magnitude cheaper than previous robots. And I'm just wondering, are we going to develop the App Store equivalent of capabilities for these kinds of new machines? Because now we have the bodies that are reasonable in cost, at least for research grade. I'm sure the cost will continue to go down. And so I'm kind of excited about this vision that we have. We get the bodies, we get the good hardware, we get reliable hardware platforms, and then we have a whole team of computer scientists and AI researchers and engineers around the world essentially developing capabilities, much like what we did with a smartphone, which was interesting when it arrived. But then what really made it powerful, what really democratized computations with a smartphone is the App Store that made it possible for so many applications and so many custom applications to be run on the machine. So I'm very excited about that vision. And I will tell you another example. One of the first drones was actually done by students of mine at MIT, a couple of German students. Then they went to Germany and they started a company called Ascending Technologies some 15 years ago or so. And they were selling robots for 30,000 euros. Okay, those were extraordinarily great robots and they were fantastic for research. That domain stayed within the field of research until DJI came up with $2,000 platforms, and now all of a sudden so many more people had access to this notion of using drones. And today I can buy a $50 drone that allows me to take photographs in extraordinarily creative ways that I could not do with just the camera on a stick. And so I actually, and this transformation happened over about 10 years. So I do have confidence that we will see the same kind of transformation for other platforms, for humanoids, for legged robots, for wheel-based platforms that can become very efficient luggage robots, Yanling. So we're working on that. Okay, we have a number of questions from all of you. Thank you for sending really thoughtful questions. So I think I have time to ask at least a couple of them. And so here's an interesting question. For humans, we are sensors first before intelligence. In other words, a newborn baby. For physical AI, it's reverse. And we build the model and then sensors. Why? Anybody want to take this? Gaurav?
Well, I mean, I think the reason why is because engineering is often easier that way. It's really not a good scientific answer. There are people who have argued that what you want to do is to co-evolve the body and the brain together, and there's a whole field of physical intelligence that deals with that. So maybe that's an alternate way of doing it. But from an engineering system point of view, it's almost always easier to build a body and then write software. It's been the dominant paradigm for 50 years, but it's worth questioning.
Okay, our time was just shrunk by 10 minutes because Jinhua says everyone needs a break. So, so let's end on the following question. Can you each describe an interesting scenario that you consider possible in the next 50 years related to physical intelligence? I don't want 50 years. It's too long. Let's just say 5 years. 5 years. So David, what do you want? What's your dream scenario for 5 years from now?
Okay, very quickly. I think for vision technology, it's something that is very doable. So actually today in aerospace, you can use drones for inspection, but some engineer need to look through the full footage and make a decision. There's no decision support at all. You're not allowed to because of the accountability issue that I'm talking about. There's two parts. One is identifying, getting to the spot where the engineer need not climb onto the airplane, understand what defect are we looking at, and also replan the work, because this replanning of work is something that today is very challenging in maintenance. You have 100% trying to get access to the plane and do something, and now when you have a finding, there are a lot of issues or you need to resequence many things, and the critical path changes. And to plan for such things is very difficult for us to do it in an optimal way because of the various parameter, and all that I think is something that's very achievable to connect all these pieces, and then after that bring in the right robots to do some specific tasks.
Yanling.
Okay, the 5 years one is easy because it's in my work plan. And that is to deliver autonomous vehicles, and you would, as passengers of Changi Airport, hopefully see autonomous vehicles delivering your bags to and from the aircraft itself. What I thought is interesting is 50 years, right? In 50 years, what would aircraft handling be like? And in our company, we have a vision for this. We're hoping that aircraft turnaround, instead of having the average of 7, 10 men doing turnaround of aircraft, could we have done it with 5 men, 4 men, 3 men, 2 men? Can you imagine that ever happening? And that's where we want to be headed for. Yeah.
Well, you opened the 50 years thing, so I have to ask you, are we still going to fly in big planes in 50 years, or will we have our own flying cars?
I think you need to fly at some point in time, right? So unless I
want to fly in my car.
Yeah, possible, but fly from where? I think that's a question, right? Yeah, and then I think physical transportation is still important. Unless we could, bite-size ourselves, we need to move physical atoms, isn't it? Yeah, so which is why marine transportation, aviation would continue. Maybe not in that form, perhaps. But the whole idea of being able to do aviation with less than 50,000 people that I have today, I think that would be a dream to achieve. Yeah.
Well, I personally want to be Iron Man in 50 years. Gaurav
will deliver that. No?
So, the joke in robotics very often is that there are two kinds of roboticists. One kind works really hard to make sure that their robots never, ever come into contact with the environment. Autonomous vehicles, the sole purpose, getting from A to B is an important thing, but don't hit anything, right? It's super important. There's another kind of robotics where the entire purpose of the robot is to touch the environment, pick stuff up, move it around. I look forward to progress on the second one. It's a much, much harder problem. AVs are remarkably difficult, but you haven't seen anything yet if you decide to, in fact, embrace the world. So robots that embrace the world. 5 years.
It's true. Yeah. It's true. In fact, right now, it is much easier to send a robot to Mars than to get a robot to clear your dinner table. And so 5 years' time, okay, Gaurav, I'm going to hold you to it. Sao Xiong.
Yeah, I think 5 years is also a very hard landscape to even navigate.
You can go to 50 if you want.
No, I'm saying that it's so unpredictable at this point in time, right? Things are still so evolving so much. If you talk about 2 years ago, we never even imagined something like ChatGPT coming out. So 2 years is already such a long time frame, right? I think 5 years, what I really hope to see is autonomous vehicles, real autonomous vehicles. Not the kind of trials.
You mean robotaxi? Because we have a lot of autonomous vehicles right now.
Yeah, robotaxis. I rode in one recently, Waymo, when I went to San Francisco. I think that was fantastic, but it sort of had like a steering wheel and it was turning around, and I thought it was like an invisible man driving the car actually, because it looks exactly like a normal car except that there was no one driving it. I was looking at something really truly robotaxi. There's no driver, there's no even front seat, and literally the car will bring people around. So I'm a little bit more near term kind of focus.
I want to quote one of my colleagues who rides autonomous taxis in San Francisco every time he has a chance. And he says, yes, Daniela, 8 out of 10 times, everything went well. 2 out of 10 times, I was afraid for my life. So I think that we still have some. I'm glad your experience was a positive one. But
it
there's
was
still
one of those 8 times.
Yeah.
But
So I mean,
wanna-
the point is that it's a hard problem and it's not fully solved. I don't know if we can give you level 5 autonomy in 5 years, but
Yeah,
we'll try.
But I'm saying that even like, out of 10 times, even with a human driver, you can't get 100% either, right? So just put it out there.
Yes, we've had some experiences like that also. Armando, you have the last word.
One of the things that I would really look forward in the next, and I think it's pretty doable in the next 5 years, is to have a platform for, let's say, home robotics that is not just a device like a Roomba that only does one thing, but that really has the platform that allows the kind of inventiveness that we see in the digital world, that allows different people to program it for different things, that has the APIs at the level of abstraction that allows people who might not be really hardcore robotics experts to play with new applications and new ways of using it for different tasks. I think we need to get a certain level of the primitives, get the primitives to a certain level of quality so that people can then build on top of that and really unlock all the creativity of the broader technical community to explore the kind of really useful applications that could really transform our lives.
And you can all be part of that. So let's give a big round of applause to this panel.